Hello everyone, I am BronyCalc, and today I will be talking to you about the 2017 Amc 12A, problem number 23. Now, this problem has already been covered by probably several people, but most notably the website Art of Problem Solving and their creator Richard Russick, and they have a great solution. I recommend you check it out. I will put the link in the description. But I have a solution that I think has a few advantages I will get into in a second. But before I can talk about that, I need to talk about the problem itself. So we're given a polynomial, g of x equals x cubed, so we have a monic cubic polynomial, plus ax squared plus x plus 10. And this has three distinct roots. I'm going to write them here, but they actually aren't used in my solution at all. They're just to help me explain some things later on. We have a second polynomial in the problem, f of x. This is equal to x to the fourth, so now we have a monic quartic polynomial, plus x cubed plus bx squared plus 100x plus c. And this has the same three roots plus one more. Now, the Richard Russick solution would be to multiply g of x by x minus r4, and since now they have the same roots, same degree, linear times a cubic is a quartic, and they have the same leading coefficient, that would make these equal. I'm not really a fan of this solution, however, because it introduces this new clunky variable, and we actually don't need to do that at all. Instead of x minus r4 g of x, we can just use x times g of x, which is x to the fourth plus ax cubed plus x squared plus 10x plus 0. And this has roots r1, r2, r3, and 0. So, now we can do something a little interesting. We can try subtracting these two polynomials from each other. It's easy to see that since r1, r2, and r3 are roots of f of x and xg of x, they'll be roots of this difference, which from now on I will be calling h of x. So if we were to calculate h of x, we would get 1 minus a x cubed, since x fourth minus x fourth is 0, plus b minus 1 x squared plus 90x plus c. So, now there's an important observation here that is the crux of the whole idea, of the whole solution. G of x and h of x have the same degree. They're both cubics. They have the same roots, and since they're distinct, we don't have to worry about multiplicities, we don't have to worry about what if this one's showing up twice in this one and only once in this one or anything like that. We know exactly how many times they're showing up and which ones they are. So that's nice. The only real difference I see is the leading coefficient. But if we fix that by multiplying g of x by 1 minus a, now we have two polynomials. This one is 1 minus ax cubed plus a 1 minus a x squared plus 1 minus a x plus 10 times 1 minus a, and it has the roots r1, r2, r3. We didn't change any of the roots, we didn't add any, we didn't subtract any, we just multiplied by a constant, which means these two have to be equal. So, if these are equal, then every single one of their coefficients is equal. I'm going to erase this. I'm going to bring f of x back at the very end. I'll explain why after I'm done. But if we can equate all of these coefficients, then we can find what a, b, and c are. Easiest one to find right off the bat is a. 90 is equal to 1 minus a is equal to negative a9. Then we look for c. C is 10 times 1 minus a. Well, 1 minus a is just 90, so that means that C is 900. and b minus 1 is equal to a 1 minus a, and we have to be careful about this. This is b minus 1, not b. I almost made that mistake during the test. It wouldn't cost you any points. You'll figure it out pretty quick, but it does cost you a few seconds, which is something you really want to save on a time-intensive test like the AMCs. So it's 1 plus a times 1 minus a, which is 1 minus 89 times 90. Now, 89 times 90 is 8,010. So we can just do 1 minus that. We get negative 8,009. Pardon my writing. Society was not built for left-handed people. So we've got all three of these variables, but none of them are the solution. So the solution is asking for f of 1. So f of 1 is equal to, well, we have 1 to the 4th, which is just 1. 1 cubed, also 1. b times 1 squared, which is b, which is negative 8,009. Plus 100 times 1, this is 100. Plus c is 900. So 100 and 900 add up to 1,000, and negative 8,009 and 1 is negative 8,007. If we add these together, we get a final answer of negative 7,007, which is C. As I stated earlier, this solution has a few advantages over the common solution of introducing the variable r or r4 or whatever to represent the extra root of f of x. We don't use any new variables whatsoever, so we're not adding any unnecessary complications to the problem. And I've actually tested this and explained it to some of my less mathematically inclined friends, and they agreed that this was more or easy to understand than the solution on our problem-solving wiki, which also introduces this r but uses Vietta's formulas instead, which is an interesting decision. It's a lot longer, I must say. So this is shorter and easier to understand than the Vietta solution, and less complicated than the Richard Russick solution. Anyways, I hope you enjoyed it. Don't forget to like and comment on the video, and if you want to see more stuff like this, consider subscribing and ringing that bell for notifications. Thank you for watching. I will see you next time.